Hello student, today we want to conclude this topic carbon and its compound from two last topic. I hope last video we have discussed how laboratory preparation of carbon dioxide gas, carbon dioxide gas and their property. Our lesson today we are going to start carbonate and hydrogen carbonate. Carbonate are salts from salts of metal and metal ions and ammonium ions with carbonate. So if you see metal carbonate and ammonium carbonate, those one are carbonate salts. The carbonate ions are indirectly obtained from carbonic acid formed when carbon dioxide gas is dissolved in water. Remember we have said carbon dioxide gas is soluble in water. When it dissolves in water, it forms carbonic acid. Hydrogen carbonate are salts derived from carbonic acid formed by partial displacement of hydrogen by metal or ammonium radical. Hydrogen carbonate of sodium, potassium and ammonium exist in solid form at room temperature, whereas those of calcium and magnesium only exist in solution form. The hydrogen carbonate of other metals do not exist. Reaction of carbonate and hydrogen carbonate with dilute acid. This one is very simple as long as you remember from one work. Acid plus carbonate we get salt plus water plus carbon dioxide gas. Acid plus hydrogen carbonate the same, we get salt plus water plus carbon dioxide gas. All carbonate give off carbon dioxide gas when reacted with acid. For example, calcium carbonate plus hydrochloric acid, we get calcium chloride plus water plus carbon dioxide. Zinc carbonate plus hydrochloric acid, we get zinc chloride plus water plus carbon dioxide gas. Sodium hydrogen carbonate plus hydrochloric acid, we get sodium chloride plus water plus carbon dioxide gas. Lead carbonate plus nitric acid, we get lead 2 nitrate plus water plus carbon dioxide gas. Sodium carbonate plus sulfuric acid, we get sodium sulfate plus water plus carbon dioxide gas. In short, metal carbonate plus hydrogen carbonate, they form salt plus water plus carbon dioxide gas. Next part, we go to the reaction between calcium carbonate and lead carbonate with dilute sulfuric acid does not go for completion. This is due to the formation of insoluble calcium sulfate, lead sulfate respectively. Since we have said all sulfate are soluble in water except lead, calcium and barium. Calcium is slightly soluble in water. When you are using with this metal carbonate with sulfuric acid, remember the reaction will not undergo completion due to the formation of insoluble sulfate, which forms a coat on the surface of carbonate and prevent further reaction. The reaction between lead carbonate and hydrochloric acid also does not undergo completion because of the formation of insoluble lead 2 chloride. We have said all chloride are soluble except lead and silver. They form a coat on the surface of carbonate, preventing further reaction. Calcium carbonate plus sulfuric, we have calcium sulfate plus water plus carbon dioxide gas. Calcium sulfate forms a white precipitate because of insoluble sulfates. Lead carbonate plus sulfuric acid, we have lead sulfate plus carbon dioxide gas plus water. Next we have lead carbonate plus hydrochloric acid, they form lead chloride plus carbon dioxide gas plus water. So in short, all carbonate and metal hydrogen carbonate, when they react with acid, they form salt plus water plus carbon dioxide gas. Next, now we go to action of heat on carbonate and hydrogen carbonate. All carbonate except carbonate of potassium and sodium decompose when heated to form metal oxide plus carbon dioxide gas. They told us all metal carbonate decompose on heat to form metal oxide and carbon dioxide gas except potassium and sodium. These two, they are stable carbonates, they are not affected by heat. So equation we have copper 2 carbonates decompose on heat to form copper 2 oxide plus carbon dioxide gas. Lead 2 carbonate decompose on heat to form lead 2 oxide plus carbon dioxide gas. Zinc carbonate decompose on heat to form zinc oxide plus carbon dioxide gas. And calcium carbonate decompose on heat to form calcium oxide plus carbon dioxide gas. So metal carbonates, apart from potassium carbonate and sodium carbonate, others they decompose on heat to form metal oxide plus carbon dioxide gas. Then we need to know ammonium carbonates decompose on heat to form ammonia gas plus carbon dioxide gas plus water. And here we have the equation. Ammonium carbonate, when it decomposes on heat, it forms ammonia gas plus carbon dioxide gas plus water. Hydrogen carbonate decomposes on heat to form metal carbonate plus carbon dioxide gas plus water. All metal hydrogen carbonate, when it decomposes in heat, they form metal carbonates plus carbon dioxide gas plus water. Example, we have sodium hydrogen carbonate decompose on heat to form sodium carbonate plus carbon dioxide gas plus water. Potassium hydrogen carbonate also decompose on heat to form potassium carbonate plus carbon dioxide gas plus water. The same to calcium hydrogen carbonate decompose on heat to form calcium carbonate plus water plus carbon dioxide gas. The calcium carbonate is further decomposed by the heat to produce an oxide and hydrogen carbonate, an oxide. So now we have calcium carbonate decompose further to form calcium oxide plus carbon dioxide gas. This one is error, hydrogen is not there. Then now we go to large scale manufacture of sodium carbonate and sodium hydrogen carbonate. Large scale production of sodium carbonate and sodium hydrogen carbonate. Sodium carbonate is an example is an important raw material in glass and paper industries. It also used in water treatment plants. This important raw materials is obtained in two ways. One, extraction from trona and preparation of solvay by solvay process. Let me discuss one by one. First, how can we obtain sodium carbonate from trona? Extraction from trona. Trona is a double salt containing sodium carbonate, sodium hydrogen carbonate, and 2 mole of water. And here we have the chemical equation of trona: sodium carbonate, sodium hydrogen carbonate, and 2 mole of water. This one found in Lake Megadi in Rift Valley. In lakes in Rift Valley and also in Lake Megadi is a good example of this. So now here we have a trona. We have said trona is a double salt. It contains sodium hydrogen carbonate, and 2 mole of water. From the lake we pass through a washery. We wash using water to get. Now the role of this chamber is to remove the mud and the small rocks. So we get a wet trona. Then we go to centrifuge is to remove water. A dry trona it goes direct to a chamber called a kiln. Kiln now heat is involved. So when we heat sodium carbonate, sodium hydrogen carbonate, and 2 mole of water will remain. Water will be removed, but remain the sodium carbonate and sodium hydrogen carbonate. Then we pass through heat exchanger where it heats further to obtain sodium. So when we heat sodium carbonate, sodium hydrogen carbonate, we get sodium carbonate plus water plus carbon dioxide gas. The sodium carbonate we obtain here is grind and chief, and lastly we store and bagging and storing for ready for transportation or usage. Lake Megadi contains large amount of solid trona and small amount of sodium chloride. Trona is dug and packed, dragged, and taken to the washery where it is washed in water to remove mud and small rocks. The wet trona is then centrifuged to remove water and purify it further. The dry trona is then heated to obtain to about 300 degrees in the kiln to decompose the sodium carbonate. And here we have the equation. The trona, sodium carbonate, sodium hydrogen carbonate, and 2 mole of water. When we heat, it forms sodium carbonate, sodium hydrogen carbonate, plus water. So sodium carbonate and sodium hydrogen carbonate further heated, we get sodium carbonate plus water plus carbon dioxide gas. The sodium carbonate obtained is cooled, ground, sealed, and packed, ready for transportation and storage to consumer. Then we go to how can we prepare solvay process. We have said there is two way of getting sodium carbonate. Very important raw materials in paper industries, glass industries, and also treatment of water. We can obtain either we can extract from trona or solvay process. How can we obtain by solvay process? In place where trona is not available, sodium carbonate and sodium hydrogen carbonate are manufactured by solvay process. In solvay process, we have three raw materials. One, sodium chloride, which we call it a brine, concentrated sodium chloride. Calcium carbonate and coke, ammonia gas obtained from HAPA process. So now here we have the diagram. The first solvay process has 4 chambers or 4 tanks. The first one is called the first absorption tower. That's the first one. The second one is ammonia generator. Third one is called carbonator, the second absorption tower. And the last we call it calcium carbonate KHEIR. So the prime, this pipe carries the prime, which we call it a sodium chloride, a concentrated sodium chloride. Then in the second, here we have ammonia generator, contains ammonia and water. This one contains ammonia and water. So ammonia and water will go to the first absorption tower where it contains brine. So ammonia combined with the brine, sodium chloride, to form, now they pass through this pipe with this a process called brine saturated with ammonia called brine. Then it goes to the second absorption tower called carbonator. So this chamber is called carbonator. All substances that contain carbon will go direct to the carbonator. So the last one is called calcium carbonate. The kill means heat is involved here. When we heat calcium carbonate, decompose by heat to form calcium oxide. That's why here we get calcium oxide. And carbon dioxide gas, since it contains carbon, it takes to the carbonator. So here we have ammonia, we have sodium chloride, and we have carbon dioxide gas. So ammonia plus water plus the brine sodium chloride, they react to form sodium chloride plus calcium hydroxide. It forms sodium chloride plus sodium hydrogen carbonate. You see? So sodium hydrogen carbonate is insoluble in water, while ammonium chloride is soluble. So when we add water, here now we have filter. So in this chamber we get ammonium chloride and sodium hydrogen carbonate. We add water, ammonium chloride plus water remains as a filtrate, while sodium hydrogen carbonate will be the residue. So since this now the filtrate contains ammonia, we take back to ammonia generator. Sodium hydrogen carbonate, we take to a roaster, another chamber called a roaster, where heat involves sodium hydrogen carbonate. When we heat, we get sodium carbonate plus water plus carbon dioxide gas. Water will turn, so carbon dioxide gas will go back to the carbonator, where we say this one, all carbonator will go, all substance that contains carbon will be carried to carbonator. So the water, after now heating sodium hydrogen carbonate, I have said we get sodium carbonate plus water plus carbon dioxide gas. Carbon dioxide gas we have taken to the carbonator. So the water, it will go back to the coke where it reacts with calcium oxide. Calcium oxide plus water, we get calcium hydroxide, and we take to the second chamber, we call it ammonia generator. So in ammonia generator we have ammonium chloride and calcium hydroxide. Ammonium chloride and calcium hydroxide, they react to form a substance which a byproduct. The substance is calcium chloride. So the only byproduct here we obtain is calcium chloride. Remember, byproducts are those substances that we don't need it, but they just come out. So here now we have recycled water, we have recycled carbon dioxide gas, and if you remember here ammonium chloride, we have also recycled to ammonia generator. So what we obtain here is sodium carbonate, and that was the main aim. The main aim of this process is to obtain sodium carbonate, and we get calcium chloride as a byproduct. So let's discuss. Ammonia is dissolved in brine in a solvator to form ammonical brine. A lot of heat is produced in the process. The amount of heat produced is controlled by the regulation of the flow of brine into the solvator. The ammonical brine is then pumped into the carbonator from the top, where it tracks down and down the carbonator, while carbon dioxide from the keel is pumped from the base. The carbonator has to be cooled regularly to reduce the amount of heat produced in it. Sodium hydrogen carbonate, being less soluble than ammonium chloride at low temperature, form crystals in the lower cool parts of the carbonator. The reaction takes place in the carbonator as follows: ammonia plus carbon dioxide gas plus water, they form ammonium hydrogen carbonate. Ammonia plus carbon dioxide gas plus water, we get ammonium hydrogen carbonate. Ammonium hydrogen carbonate plus sodium chloride, we get sodium hydrogen carbonate plus ammonium chloride. And here we have a double displacement reaction. The reaction in the carbonator can be summarized by the equation below. Ammonia plus carbon dioxide gas, we get plus sodium carbonate plus water, we get sodium hydrogen carbonate plus ammonia chloride. And this is the word a chemical equation. Sodium hydrogen carbonate is separated from the ammonia chloride by filtration. Sodium hydrogen carbonate is dried and decomposed by the heat at 300 degrees centigrade to produce sodium carbonate. And here we have the equation: sodium hydrogen carbonate, when we heat, we get sodium carbonate plus carbon dioxide gas. The calcium oxide produced in the limestone kiln is slugged, combined with water and mixed with the filtered ammonium chloride to produce ammonia gas, carbon dioxide, and calcium chloride. Calcium hydrogen carbonate plus ammonium chloride, they form calcium chloride plus water plus ammonia. The solvay process is one of the best examples of efficient industrial chemical process because pollution problems are considerably reduced. The carbon dioxide and ammonia gas produced are recycled to minimize cost, and calcium chloride is the byproduct. In a brief, the only byproduct which is not recycled is calcium chloride. Recyclable and recycled substances are ammonia, water, and carbon dioxide. Some sodium carbonate is used in water softening, glass making industry, paper industry, and making of sodium silicate. The sodium silicate is used in making detergent. Sodium hydrogen carbonate is used in making healthy drinks and as baking powder in the food. Calcium chloride is used as a drying agent in the school laboratory preparation of gases. In downcell process of extraction of sodium to lower the melting point of the rock salt, used as a food additive, for preservative, and used for de-icing road in winter. The best site of the solvay process should be close to the river or large source of water to cool down the carbonator. Next, now we go to effect of carbon dioxide gas and carbon dioxide gas to the environment. The level of carbon dioxide gas in the atmosphere is increasing due to the use of fossil fuels such as petrol, diesel, natural gases, and the coal. The increase the causing global warming due to the greenhouse effect. Some of these effects of global warming include melting and polar ice cap, which led to the rise in the seawater level and erratic weather pattern. Vehicles exhaust fuel making up more than 60% of all carbon dioxide emitted into the atmosphere. Carbon dioxide emissions are highest during cold weather. This is because low temperature make combustion less complete. Carbon dioxide gas can cause death through suffocation. Luckily, carbon dioxide gas is quietly removed from the atmosphere by microorganisms in the soil. Last subtopic is now carbon cycle. The way in which carbon compounds circulate in the nature constitutes the carbon cycle, which is shown below. The process that release carbon dioxide to the atmosphere include combustion. When we combustion of fuel, when we burn a fuel, it releases carbon dioxide to the atmosphere. Respiration in both animals and plants. Fermentation, decomposition of carbonate and hydrogen carbonate. The process that remove carbon dioxide in the atmosphere include photosynthesis in plants, dissolving carbon dioxide in seas and oceans. The amount of carbon dioxide in the atmosphere has remained fairly constant of 0.03% owing to the dedicated balance between the process that absorb the gas and those that evolve it. Later, the balance is being interfered with by human activity, leading to an increase in the level of carbon dioxide in the atmosphere, thus causing global warming, since carbon dioxide gas has a greenhouse effect. And here we have the diagram and the flow chart. So here now, when we burn a petrol, we call it a combustion, it releases carbon dioxide to the atmosphere. Also, plants during respiration, it absorbs during respiration. Plant uses oxygen. It releases carbon dioxide gas to the atmosphere. But opposite of respiration, we call it photosynthesis. Absorb carbon dioxide from atmosphere. Plant feeding, animals feed on plants. Animals also they respire. During respire, they release carbon dioxide to the atmosphere. Then plants also respire. During respiration, they release carbon dioxide to the carbon dioxide in seas and oceans. And also during photosynthesis, they absorb carbon dioxide gas from oceans and seas. Seas, they dissolve water, they absorb carbon dioxide gas, we call it dissolution. And this is how carbon cycle takes place. So this is the end of my video today. So let me just summarize what we have learned under carbon dioxide and now carbonate and hydrogen carbonate. So in this video we have learned carbonate and hydrogen carbonate. We have said carbonate and hydrogen carbonate, when they dissolve, when they decompose on heat. Let me first of all shrink. We have said carbonate and hydrogen carbonate. Carbonate and hydrogen carbonate when they decompose on heat. All metal carbonate decompose on heat to form metal oxide plus carbon dioxide gas except two. That is sodium and potassium, most reactive metals. The remaining metal carbonate they decompose on heat to form metal oxide plus carbon dioxide gas, except sodium and potassium. They are stable carbonate. Next, we have learned hydrogen carbonate, effect of heat on hydrogen carbonate. Also, we have said all metal hydrogen carbonate they decompose on heat to form metal carbonate plus water plus carbon dioxide gas. We have said sodium carbonate is now important raw materials in paper industries, glass industries, and also in treatment of water. We can obtain in two ways. We can extract from trona, where we have said trona is a double salt, that is sodium carbonate, sodium hydrogen carbonate, and 2 mole of water. At places where trona is not available, we can prepare solvay process. And lastly, we have discussed solvay process, how things occur, and also effect of carbon dioxide and carbon dioxide to the atmosphere, to the environment. When we release carbon dioxide gas to the atmosphere, it dissolves in rainwater to form carbonic acid, and it comes down as an acid rain. And you know the effect of acid rain, it causes corrosion in metal sheet and roofs. It reduces soil fertility. Then we have said the other effect of carbon dioxide gas. Once you inhale It combines with hemoglobin to form carboxyhemoglobin, which reduces the carrying capacity of oxygen. Hence, it leads to suffocate. Suffocate means you die due to lack of oxygen. And after we have discussed how carbon cycles in our nature. That's the end of the topic. Wish you good luck.